Does the current state of theoretical physics bother you? Specifically the quantum quandary? What are its implications? In the grand tapestry of knowledge, theoretical physics weaves its complex and intricate patterns, often leaving even the sharpest minds tangled in its threads. One such knot in this intellectual fabric is the quantum quandary, a modern conundrum that has left this generation of theoretical physicists both perplexed and exasperated. Imagine being a brilliant, ambitious young physicist, eager to decipher the mysteries of the universe, only to find yourself entangled in an incomplete theoretical framework that is as challenging to master as it is elusive in its rewards. This is not a mere academic hurdle, but a labyrinth of questions that ultimately seems to lead to a dead end. Take, for instance, the concept of quantum entanglement. Despite its central role in applying quantum mechanics to esoteric technologies, it remains a source of great debate and uncertainty. Einstein himself described it as spooky action at a distance, and yet it is clearly a part of our understanding of the quantum world. And then there's the bias towards thinking outside the box, a virtue in many fields, but a potential handicap in an arena where the box itself is not fully understood. This bias often leads to theories that, while innovative, may not fully align with the established framework of physics. This can result in theories that are as tantalizing as they are elusive, adding to the frustration and confusion of investigators. Moreover, the foundations of our understanding, the very basics like definitions of fundamentals, are often taken for granted. We use numbers, right lines, and circles in algebra and geometry, but do we really understand them within the constraints we are given? Perhaps it's time to consider the mutual properties of these fundamentals, to revisit the wisdom of ancient views that might have been dismissed prematurely by modern investigators. After all, the key to unraveling the quantum quandary may lie not in the unexplored frontiers of physics, but in the very basics that we thought we understood. This quantum quandary is a perplexing problem indeed, but it's just the tip of the iceberg. Theoretical physics is more than just a field of study. It's a complex labyrinth that's difficult to navigate. The complexities of this discipline are not just about the intricate mathematical equations or the abstract concepts it deals with. It's also about the prevailing biases that can sometimes hinder progress and lead us into dead ends. Consider, for example, the established bias for conventional thinking. This is an essential aspect of theoretical physics, as it propels us to explore new frontiers and challenge established norms. However, it can also lead to a form of tunnel vision, where we become so fixated on thinking outside the box that we overlook the insights that can be gleaned from established theories. A classic example of this is the pursuit of string theory. Despite decades of research and countless resources invested, it remains a mathematical framework with no empirical evidence to support it. It's a beautiful, elegant theory that has captivated many brilliant minds, but its inability to make testable predictions has led some to question whether it's a futile exercise in mathematical gymnastics. Another challenge in mastering theoretical physics is the lack of deep understanding of the basics, like the definitions of fundamentals. We're dealing with concepts that aren't just complex, they're often counterintuitive. Quantum mechanics, for instance, has defied our intuition at every turn. Without a solid grasp of the basics, it becomes all too easy to get lost in the labyrinth. Take, for instance, the concept of a quantum state. It's a fundamental idea in quantum mechanics, yet it's one that many struggle to comprehend. It's this lack of understanding that can lead to misconceptions and erroneous conclusions. It's like trying to build a skyscraper on a shaky foundation. Mastering theoretical physics is indeed a daunting task, given the constraints and biases that exist. It's a journey that requires not just intellect and creativity, but also a deep understanding of the fundamentals and the humility to recognize and challenge our own biases. Only then can we hope to navigate this labyrinth and uncover the secrets it holds. Could the solution to our quantum quandary lie in a better understanding of the basics? This might seem like a step backward, but sometimes, to move forward, we need to take a few steps back. The key might not lie in the complex, but in the simple. In the numbers, right lines, and circles that form the fundamental building blocks of our mathematical understanding. Numbers, right lines, and circles. These are the fundamental tools that have been used for centuries in our quest to understand the universe, and yet how well do we truly understand them? Let's take numbers, for instance. We manipulate them, we calculate with them, we base our entire understanding of the universe on them. But do we really understand them within the constraints that we are given in the numbers of algebra? Right lines or straight lines and circles are the basic entities of geometry. Again, we use them in calculations, we draw them, we base our understanding of space and time on them. But do we truly understand their mutual properties, their inherent characteristics, and their relationship with each other and with numbers? The ancient Greeks, for instance, had a profound understanding of these fundamentals. They saw numbers not just as tools for calculation, but as entities with inherent properties and relationships. They saw right lines and circles not just as geometric shapes, but as representations of fundamental truths about the universe. They believed that by understanding the mutual properties of numbers, right lines, and circles, one could gain a deeper understanding of the universe. Modern investigators, however, tend to dismiss these ancient views as primitive or simplistic. We tend to focus on the complex, the abstract, and the esoteric. We are so eager to think outside the box that we often forget to fully understand the box itself. But what if these ancient views hold some value? What if, by going back to basics, we could gain new insights into the quantum quandary that is confounding our generation of theoretical physicists? What if the key to understanding the universe lies not in the complex equations of quantum mechanics, but in the simple properties of numbers, right lines, and circles? This is not to suggest that we abandon our modern theories and return to the thinking of the ancient Greeks. Rather, it is a call to complement our complex theories with a deeper understanding of the fundamentals, to think not just outside the box, but also inside it. To remember that even the most complex theories are built on the simple fundamentals of numbers, right lines, and circles. Going back to basics might seem counterintuitive, but it could be the key to unlocking the mysteries of theoretical physics. This is not a solution, but a suggestion, a potential path to explore in our ongoing quest to understand the universe. A reminder that sometimes, to move forward, we need to take a few steps back. Theoretical physics, in essence, is a journey of exploration and discovery. It is akin to venturing into a vast, uncharted wilderness, armed only with the tools of the mind, curiosity, reason, and a relentless drive to uncover the truths that lie hidden beneath the surface of reality. It's not for the faint of heart. It requires the courage to question, to probe, to challenge the established and the accepted. This journey demands an open mind, a willingness to question the very foundations of our knowledge. In the realm of theoretical physics, nothing is sacred. The laws of nature, the principles of mathematics, the constants of the universe, all are subject to scrutiny, to doubt, to revision. The quantum quandary, this perplexing and exasperating enigma that has confounded this generation of theoretical physicists, may well be an intrinsic part of this journey. It may be a hurdle that we need to overcome, a riddle that we need to solve, to progress further in our quest for understanding. Frustration, indeed, is a familiar companion on this journey. But frustration is not a sign of failure. It is rather a sign of being on the right track, of pushing against the boundaries of our knowledge, of grappling with problems that are truly challenging, truly worth solving. The quantum quandary is a challenge, but it's also an opportunity to revisit the fundamentals, to question the assumptions, to explore the possibilities. It's an invitation to think outside the box, to break free from the constraints of conventional thinking, to venture into the unknown. Theoretical physics is not just about finding answers. It's about asking the right questions. It's about the journey, the exploration, the discovery. The quantum quandary, this seemingly insurmountable problem, may well be the key that unlocks a whole new understanding of the universe. The quantum quandary is a challenge, but it's also an opportunity for growth and discovery. So, where does that leave us in our understanding of the quantum quandary in theoretical physics? This is a question that's not only fascinating, but also deeply challenging. We've explored the modern conundrum, the complexities of mastering a field so intricate yet seemingly leading nowhere, and the importance of fundamentals, numbers, right lines, and circles. Young theorists have an uphill battle dealing with an incomplete theoretical framework and the bias against out-of-the-box thinking. Yet, despite these challenges, it's necessary to maintain an open mind. It's worth considering whether we fully understand numbers within the constraints of algebra and geometry. Might there be more to these fundamentals? Could the wisdom of ancient views on these three fundamentals offer some insights? The quantum quandary is indeed a complex and perplexing problem. It's a puzzle that's exasperating, yet captivating, for it's through solving it that we might just unlock more of the secrets of the universe. So, the quantum quandary is a complex and perplexing problem, but it's also a fascinating puzzle that promises to help unlock the secrets of the universe. Stay tuned for more to come, much more.